Hi everyone! In the previous videos we had looked at creating a Pokemon dynamic web project in the first video, and in the second video we looked at actually reviewing arrays in Java and then array lists in Java, and then how we could add Pokemon to an array list and display them using JSTL code. So again from the previous videos, we have our Pokemon page and we had an ordered list of Pokemon. We have Pikachu, Charizard, we have Jigglypuff, and we have Mewtwo. Now, if you notice something about the way in which our Pokemon are displayed on our JSP page, they are displayed in the order in which we added them to our array list. So over in my servlet, you can see we added Pikachu first, we added Charizard, we added Jigglypuff, and we added Mewtwo. And over on our JSP page, it is displayed as Pikachu, Charizard, Jigglypuff, and Mewtwo. They match up perfectly. We can actually sort array lists. That's one of the very powerful features that are in array lists, is their ability to sort them. So just like in SQL, you could actually, if you could imagine these Pokemon being in a table, you could use SQL to request these Pokemon, and then you could use SQL to sort them by their index number or their Pokédex number, their name, by their weight, by their height, or by their gender, or the vast combinations therein. We can do this in Java. However, unlike SQL, Java is an imperative language. SQL is declarative, and SQL, all you said was give me all the Pokemon ordered alphabetically by name, and SQL just went ahead and did that for you. However, our Pokemon over in Java are stored in a Pokemon Java bean. And Java has no idea how to sort these Pokemon Java beans. It has no idea. We need to tell Java how to sort our Java beans. Again, Java has no idea. Should Java sort it by Pokédex number, by its name, by weight, by height, by gender, by the memory address that each element has in RAM? I mean, Java has no clue. We need to tell Java how to sort things, and the way we tell Java how to sort things is with comparators. And so comparators allow us to sort our array lists. So what I'm going to go ahead and do is I'm going to go ahead and I'm going to add a comparator into my models project. So I'm going to go ahead and comparators are just classes, and we're going to add a new Pokemon comparator. Now, how should we sort Pokemon first? I think we'll sort them by national index, Pokemon index number first. I think that's a good start. So we'll say national Pokédex number comparator. Kind of got a long name here. So what we're going to do though is we're going to create a new comparator class. All comparators need to inherit from the comparator in the Java util library. So again, we need to inherit from Java util.comparator. Before I click next, I'm going to change this T to Pokemon Java bean. We need to tell this comparator class what we're sorting. This comparator is indeed sorting Pokemon Java bean. So I'm going to go ahead and click finish. So it's going to go ahead. The tool is going to create our national Pokédex number comparator class for us. The first thing it's going to do is it's going to complain. It's going to complain because we have unimplemented methods. Again, we're implementing this comparator class, so we need to go ahead and fulfill our end of the bargain. I'm going to hover over this and I'm going to add unimplemented methods. And it's going to give us a compare method. It's going to give us a compare method, again, to hold up our end of the deal of implementing this comparator interface. We need to implement a compare method. You can see we need to implement a public compare method that returns an integer. We'll talk about that in a moment. And we're going to compare two Pokemon Java Beans. Again, this is giving these a name of O1 and O2 of the two Pokemon Java Beans we're going to compare. I think the first thing I'm going to do is I'm going to change the name of these parameters. I'm going to change this to P1 and P2 instead of O1 and O2. Now, the way comparators work, I'm going to make a new Java doc, a new Java doc comment to describe how this comparator works. So comparators basically return one of three numbers, and so basically what we're going to do is we're going to have compare return -1 if P1 is less than P2. So if P1 is less than P2, we're going to return -1. If P1 is equal to P2, we're going to return 0. Likewise, we're going to return 1 if P1 is greater than P2. So again, this is how all comparators work. They return -1 if this Java bean is less than this Java bean, 0 if they would be equal, and 1 if P1 is greater than P2. Now, again, what are we comparing here? We are comparing the national Pokédex numbers. So again, I'm going to update this comment a little bit more. So we're going to return -1 if P1's national Pokédex number is less than P2's national Pokédex number. And again, we're going to return 0 if P1's national Pokédex number is equal to P2's national Pokédex number. And again, 1 if P1's national Pokédex number is greater than P2's national Pokédex number. Now, there's an easy way to implement this and a hard way to implement this. I'll show you the hard way first, because why not? So the hard way is using if and else if and else. So again, I'm going to delete this. Well, first thing I'm going to do is I'm going to create an integer called result. Then I'm going to assign it some super wonky value. In fact, I'm going to assign it the min value, an integer. I have no idea what this is. It is some colossally small number, -2 trillion or something like that. And this is a bad value. I'm going to assume a bad value by default, and I'm going to go ahead and then return that. So again, I'm going to say if P1.get Pokédex number is less than P2, get Pokédex number if P1 Pokédex number is less than P2. So we're going to set result equal to -1. Else if we're going to say if P1.get Pokédex number equals P2's .get Pokédex number. We're going to assign result equal to 0 again, as I've talked about up here. And we're going to say else. Well, we don't need to compare anything. We're going to set the result equal to 1. The only other option here would be that P2 is greater than P1, so we don't need to do anything else. And this is how we can compare Pokemon by Pokédex. So again, I've made a whole new class called National Pokédex Number Comparator. And we're going to tell that comparator how to compare our Pokemon. In this case, we're going to compare them by Pokédex number. So I'm going to save this. I'm going to save the hard way first, and I'll show you the easy way in just a moment. And we're going to go back to our Pokemon servlet, and we're going to go ahead. After we add all our Pokemon, we're going to then sort it. Again, this is more about playing with our comparators. So the way I can use Pokemon, way I can sort Pokemon is by PokemonList.sort. And we're going to pass the sort method, the comparator object. So we're going to create a new comparator object. However, I'm not going to store my comparator into a Java object. There's no need. It's a one and done object. It's just going to pop into existence. The sort method is going to sort our Pokemon for us, and we're done. So I'm just going to create a new object here. I'm going to say new national Pokédex number comparator, comparator. I don't need to pass it anything. Why are you complaining? I suppose it's because I didn't import the library. There we are. Now, Pokemon list is going to use the .sort method, and the sort method will sort our Pokemon by new national Pokédex number comparator. This sort algorithm is actually Oracle's implementation of the quicksort algorithm, which we are not going to cover here. We are not going to learn how to sort objects. We are not going to learn how to sort elements. We are going to stay extremely far away from quicksort, and we're going to use the quicksort algorithm that Oracle has provided to us, which is really awesome. This is a very efficient way of sorting objects, and we're not going to implement it. We're just going to use it. Now, let's see if our Pokemon are now sorted by national Pokédex. So I'm going to go ahead and I'm going to click the debug button to relaunch my web server. And of course, since there's already something running, I'm going to click OK. I'm going to click on my servers tab here, and I'm going to crash the server by right-clicking the server and clicking stop. And because I'm making a video, I'm going to hope this fixes it very quickly. So now I'm going to click the bug and try to relaunch my my Apache server. And there we are. We can see our Pokemon are now organized by national Pokédex number. So you can see Charizard is first at number 6. Pikachu is number 25. He appears second. Jigglypuff is number 39, he appears third, and Mewtwo should be last, he appears as number 4, and we've sorted our Pokemon using Java. So instead of using SQL, we've used Java to sort our Pokemon. Again, if I look back at my my national Pokédex number comparator, again, all comparators, this compare method must return -1 if P1 is less than P2. If they are equal, the compare methods should return 0. And if they are greater than, if P1 is greater than P2, it should return 1. Now, I'm going to show you how to do this, how to compare integers really quickly. So I'm going to keep all this. I'm just going to quickly toggle this out. I'm going to add a new block comment here, and I'm going to quickly comment that out. This is hard for me to remember what is returning -1 and 0 and 1. A little trick, a little shortcut that you can take. The integer class actually has a compare method that we can use. And so I'm going to go ahead and I'm going to compare p1.getPokédex number as the first argument to integers compare method, and then p2.getPokédex number. And all I'm going to do is I'm going to return that. And that's how we can write a comparator much quicker. So you can see integer implements a compare method, so integer must inherit from a comparator. And so I'm going to use in the integers compare method to compare P1's Pokédex number to P2. Much faster than writing branching. Again, you could use branching if you wanted to. This is much faster. I'm going to go ahead and I'm going to add another comparator. What I'm going to do is I'm going to add a name comparator. So I'm going to sort these Pokemon by name. So all I'm going to do is I'm going to right click. I'm going to add a new class. And I'm going to quickly add a name comparator. Again, comparator needs to inherit from the comparator interface. We're going to pass it a Pokemon Java bean. I'm going to go ahead and click finish. Again, I'm getting angry red squigglies, so I'm going to add the implemented compare method. I'll delete this code real quickly. As you guessed it, I'm going to compare each Pokemon name Well, first thing I'm going to do is change this to P1 and P2. I like to be consistent. And so what I'm going to do is I'm going to now compare these by Pokemon name. As you guessed it, I'm going to do it in one line of code. I'm going to say return P1.getName, and I'm going to compare that to another string. In this case, is going to be P2.P2's name. So I'm going to get that. So compare to is another way of doing this. I think string might have a, I do string.compare. No, string doesn't have a compare. Okay, well, we'll just implement it this way. This will allow me to compare P1's name to P2. Again, compare to will return -1, 0, and 1 for us. We don't need to remember that. I'm going to head over to my servlet. And instead of sorting by new national Pokédex comparator, I'm going to sort by new name comparator. Here we are. Oh, again, this is a little grumpy. We need to, instead of clicking import on this hyperlink each time and me getting scared that it's broken, I'm just going to go ahead and put a star here so I don't have to worry about this breaking every time. All right. So now I should be sorting by name comparator now. So I'm going to go ahead and I'm going to close a couple of these so it's a bit easier to see what's going on. I'm going to click the little bug to hopefully relaunch my server. Oh, Tomcat. What's going on, guy? Come on. Got stuff to do. What you doing down there? You can kind of see what, okay, it's crashing, it's already occupied. Tomcat. So Tomcat's already running. Apparently it's having a little trouble staffing. I'm gonna go ahead, I'm gonna try to click the run button here to see if I can get something to go. Tomcat. Oh, Tomcat. Why do you have to be so freaking challenging sometimes? Okay, here we go. We're gonna have to get into some drastic measures here. You can watch me struggle with this for a moment. For some reason this isn't launching. Again, if I click the bug, it's like Eclipse is ignoring me. So I'm gonna go ahead and I'm gonna close my Pokemon project. I'm going to go ahead and I'm going to close my servers, and I'm going to start pulling some drastic measures here. I'm going to close Eclipse, and I'm going to call terminal, and I'm going to call pkill -9-f tomcat8 to kill my tomcat8 process. I'm going to really hope that fixed things, and I'm going to relaunch Eclipse. I'm going to be a little frustrated if I have to pause this video and relaunch. There we are. Tomcat is now stopped. I'm going to reopen my servers project. Again, this project needs to be open. And I'm going to reopen Pokemon over here. Okay, what were we doing again? Oh, yeah. What were we doing? What were we doing indeed? We were trying to, oh yeah, sort Pokemon by name. So if Tomcat will cooperate with us finally, I'm going to click the debug button. Start to pray that this actually fixes it. Tomcat, man, Tomcat. I'm going to do the equivalent of a Control-Alt-Delete in Mac if it is Activity Monitor. Over in Activity Monitor, I'm going to do a quick sort for Tomcat. Indeed, I'm not finding it. I'm going to try to launch Tomcat from over here. Okay. I'm going to try to run this in start mode. I think this is the definition of insanity at this point, trying the same thing and starting over. I'm going to have to reboot my computer. I don't know. So I'm going to troubleshoot Tomcat. So I'm going to go ahead I'm going to pause the video now, and so in the next video, hopefully I'll have Tomcat running and we can talk about comparators. Tomcat. I'm going to pause the video. I'll be right back. Okay. After a couple frustrating minutes, it looks like what I was able to do is I had to close Eclipse, and I had to call sudo pkill -9-f. I tried sudo pkilling Tomcat 8, and I tried sudo killing Catalina. Again, this killed Tomcat, however, these servers are now running, so I'm going to stop it. And let's hope that it actually runs. So again, we're trying to compare names. So we're trying to sort names of Pokemon. I'm going to go ahead and click debug and hope that my tools can stay together long enough that I can actually see them sorted. Oh, thank you. Thank you, Tomcat. So you can see I've now finally sorted my Pokemon by name. So again, C, Charizard comes first, Jigglypuff, then Mewtwo, then Pikachu. And so I've now sorted them by name. Likewise, you could implement a float comparator to compare them by weight, height, or gender. Additionally, we could make more complicated comparators in Java. If I go to my models again, that was all closed out. Go to name comparator. Again, we can make these more complex. We could compare them, make the comparators much more complex. Again, P1, if it's less than P2, needs to be -1. So it maps to -1. If these two are equal, this compare method needs to return 0. If P1 is greater than P2, it needs to return 1. And again, this interface doesn't care how you compare them. You only need to compare them. So again, these can get pretty complicated. Now, for the sake of our sanity, this is a good exercise and all. I don't know if I would try to write very complicated comparators. That might be work better handled by SQL. Maybe not. For instance, we might want SQL to handle the sorting and of things because it does such a much better job. But for the sake of this course, this is quite helpful. Certainly, it's educational. Sorting elements and telling Java how to sort stuff. And again, this is pretty slick. So this is where I'm going to pause this video. In the next video, we're going to take a look at Java predicates. So in this video, we had looked at how to sort elements by name or by numbers and then various different ways. In the next video, we're going to use predicates to filter out Pokemon. So we're going to use it to filter away Pokemon that we don't want to see. So again, thanks for watching.